Okay, so we're building a circuit in class which has got a PIC chip in it. But what are they actually used for in the real world? A PIC chip, a programmable interface controller. It's used in so many different things. You just really are unaware of where they are. There, sheer quantity of them in your car for a start. But I want you to have a think about where they might be used. And I'm going to give you 2 examples, and then I'm asking you to think of other products that might have PIC chips in them. Because a PIC chip is something that you can program and reprogram and reprogram, and it responds to inputs, and based on what you've programmed it to do, will then control outputs as a result of what inputs are being pressed. Okay, so looking at a vending machine, in other words, a machine that you're going to put money into and it's going to give you, preferably chocolate from my point of view, but possibly drinks, crisps, whatever. That vending machine has a series of inputs. One is where the coins go in. It has to be able to register how much money has been put into the machine. So it's got to have an input that's registering the coins that have been inserted. One is that it's got to actually have some sort of keypad, because obviously if you want D9, because that's your favourite chocolate, you've got to be able to press those buttons on a keypad, and it's got to sense the fact that you have pressed them and go, okay, that's the product that we need to distribute. And it's also going to have other sensors in the machine, because it needs to know if it's run out of D9. For me, possibly a Yorkie bar, Cadbury's caramel. I'm really going for it, a massive, big slab of chocolate. But whatever that product is, it's no good if you press D9 and it goes, yeah, I'll have your money, and then you don't actually get the chocolate because there's none left. So it's got to have sensors to be able to tell that. Now the machine itself will have all sorts of other sensors. It'll know whether or not it needs to get changed, that sort of thing. But they're the 3 main inputs. The sensor that detects the coins, the keypad that detects your request, and the sensors that make sure that there's actually products to sell, that it's not empty. Process on your vending machine to turn the correct output on when it has received all of the input data requesting a particular item and a correct payment. So basically it's got to go, what have you asked for? What's your keypad input? How much does it cost? Have you put enough money in? Does it have that product? When it's checked through all of those things by running through a flowchart or a program, then it's going to turn around and say, yep, okay, I'm going to turn the motor, distribute whatever it is, and if there is any change, return the change. So that's the function of it, the process. And the output, as I say, you're going to have motors to distribute the correct product, and potentially solenoids that are going to make sure you get your change back if you need any. Big advantage for a vending machine, because you can update the program. It means that when somebody goes and refills the machine, if they want to decide to make everything 5 pence more expensive, they can just upload a new program that has got those changes. They don't have to make any changes to the hardware, to the actual machinery, or to the PCB, nothing. They just literally plug in and upload a new program to the chip. Washing machine. Your washing machine at home is going to have a PIC chip in it. Okay? The inputs are going to be whether you've got control buttons or dials. It's going to have water level sensors, things like that in it, so that it can tell what program you've asked it to run, whether or not the water's actually going in, whether the water's drained out. Process is going to be to run whichever wash cycle you've chosen. And the output, there might be a display screen to show what the cycle you've selected. There's going to be motors to turn the drum, solenoids to let the water in and out. So they're the outputs. So literally you program it, you say, this is what I want you to do. It reads those, it goes, right, well, if the owner has asked for me to run this cycle, then I need to go through these stages in my flowchart, and it will go through the different sections of the wash cycle. Advantages? This one's a big advantage for the manufacturer, because You know, one manufacturer will make 5, 6, 7 different types of washing machine, probably more. But if they want to keep their costs down, they want to have the same control board in every machine, regardless of what the cycles are. And that's exactly what they can do. They can design and manufacture one control board which goes into every different model that they make. It just has different switches and dials and LED displays and everything connected to it. But the actual control board is exactly the same, so it keeps their costs down. So, that's 2 examples I've given you. I'd like you to have a think about a microwave. I'd like you to add in what you think the inputs for the microwave are, what you think the process for the microwave is, the PIC chip within the microwave, what you think the outputs are, and what you think the advantages of using a PIC chip in a microwave is. And then finally, I want you to think of one other product that you think is going to have a PIC chip in it and repeat the process. Think about the inputs, think about what it actually functions, how it functions, what it does, think about the outputs, and then give the advantage of using a PIC chip in this circumstance.